Welcome to the Real Python Podcast. This is episode 157. Would you like to speed up your Python machine learning code dramatically? What if you only had to change a few keywords and a couple of type hints on portions of your code? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoder's weekly articles and projects. We discuss a new programming language named Mojo, which is a superset of Python. It aims to fix Python's performance and deployment problems. The project has many interesting ideas and a leader who has helped to shape modern compiler technology. We also share a pair of real Python tutorials from Leodanis Pozo Ramos about object-oriented programming in Python. The first article is a deep dive into the creation of classes. It's an excellent refresher for anyone looking to hone their OOP skills in Python. The second tutorial covers the SOLID principles, which are 5 well-established standards for improving your object-oriented design. These principles guide you to create object-oriented code that's more maintainable, extensible, scalable, and testable. We cover several other articles and projects from the Python community, including a news update, showing warnings when running Django, tracking the progress of your Python program, and a Markdown browser for your terminal. This episode is brought to you by Koyeb. Koyeb is the fastest platform to build, deploy, and scale all your Python apps. Simply git push, and your app is live on high-performance servers around the world. Deploy for free at koyeb.com. That's Koyeb.com. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back from all your travels this week.
Oh, yeah. Been on many planes.
All right, so we have a bunch of topics to dive into this week, and one we're going to kind of add a discussion onto it, but you were going to start with a couple news items, right?
Yep. Both are bits of PEP stuff. The first one is PEP 7.13 has been accepted. This one is entitled Callable Modules. If you're not familiar with that vocab, I'm sure you're familiar with the idea. Take a function, for example, if you use it without the parentheses, that's brackets in Canada, you get a reference to it. Whereas if you put the parentheses on the end, you call that, you're calling the function, right? So this process applies to other things as well. You can make an object callable by implementing dunder call on the class. And in fact, dirty little secret, some of the things in the standard library that you think are functions are actually callable classes. So this is deep into the mechanics of Python.
Yeah.
So back to the title, Callable Modules, what it's proposing doing is allowing you to use those parentheses semantics on a module as well as on a class and a function. And the primary use of this is to make your code more readable. You've probably seen things like from pprint, import pprint. That duplication kind of feels redundant. And this pattern of a function named the same thing in the module is rather common. And sometimes the function is the only thing in the module. So by making the module callable, what you essentially do is you have the module, then you'll create a special function inside of it called dunder call. And then now the module itself would be callable. So instead of doing from pprint, import pprint, you could just import pprint and call it as if it was a function.
Okay.
So obviously, they're probably not going to do it to pprint. I'm just using that as an example. So this one is slated for Python 3.12. So we should see it in the fall release. So looking forward to that.
All right. Get to play with it. See how it works.
Yep, exactly. And then PEP 7.12 is let's try this, converter parameter for data class field. What this is, data classes have been around since Python 3.7. If you haven't played with these, they're a special way of using classes where you can specify data attributes. They're pretty handy for defining things like objects that you want to deserialize some JSON into Python and bring a concept to the language, kind of like Pydantic or Django use these sort of mechanisms. They don't actually use data classes because they predate it, but it's the same kind of thing. It's that idea of creating an object that's dictionary-esque, but inside of a class.
Okay.
So speaking of Django or Pydantic, when you write a model class in those frameworks, you need to give extra information to the attribute in order to trigger side effects. So for example, if I want to use an integer in Django, I might use a positive integer field, which Django then maps to a column in the database. So data classes support a class method called field that allows you to do something similar to positive integer field thing that I was just talking about.
Okay.
If you're putting it in the data class, it's a more complex way. If I just say int, I'm stuck with an int and I can't do anything with it. So instead I use field and tell the field method that I want to do int and these other things, or I can construct something more complicated than int. So this is how you can do side effects or create things that are more complicated.
Yeah.
Once you do this, though, once you use that field method, you're losing the type info because it's no longer just a generic int. What this PEP does is add an additional parameter to the field method called converter, which allows you to specify the type, providing type check functionality back in this case where otherwise it would have been gone.
Okay.
This PEP is slated for Python 3.13, so you'll have to wait for 2024. And that means that Gerarn will be covering it in our What's New in Python 3.13 episode, as
Yes.
I have a hard time getting through anything on typing without sounding like an old man yelling at a cloud. So it'll be his turn on that one, I'm sure.
Well, you'll get a chance to talk about that more later.
I'm sure. We can argue. It's a year and a bit off. So we'll get to that argument when we get there. Maybe I'll have seen the light and I'll be the type guy by then, and maybe I'll have completely changed my mind.
That would be weird.
Stranger things have happened.
All right. So that dives us into topics, and we have a pair of really detailed and kind of amazing tutorials from Leodanis Pozo Ramos.
We should just turn Leodanis into a verb. This article is Leodanis. It means extremely detailed, and you learn lots. Yes.
Yeah, very much so. And he has took on the challenge of explaining object-oriented programming in Python. And this one is Python classes, the power of object-oriented programming. I kind of feel like this is a different presentation of OOP. This is just my opinion. It has two recognizable sort of sections to it. The first part really diving into, let's teach you OOP, and then let's teach you kind of advanced things, things that you can kind of do there. And so I wanted to present this, since it's very, very long. I'm not going to do like a summary of it, because I feel like that's kind of missing kind of the point of it here. I wanted to talk about like who would be checking out this tutorial, and do I think it would work for them or not? Would it work for a beginner? Yeah, I think if you pace yourself and you practice the techniques that are shown, there are also a lot of referenced additional tutorials. If you want to get into that more advanced sections, there are lots of sort of off-ramps to go to other real Python tutorials inside of it to dive into those details and let you kind of marinate in them a little more. Because by the end of this, it's going to seem like maybe a lot for a beginner to kind of get into. But I feel like the explanations are good and thorough for the amount of time that a single tutorial on OOP is going to allow. So I think it would work for a beginner, but the idea is that they should probably pace themselves and maybe come back and try it out. As someone who has learned OOP, object-oriented programming in Python, as a first experience, this is me, I found it to be a really great refresher. And it also added a lot of additional, I don't know, I'm going to call them gems, hiding along the way that you can kind of discover as you go, which is not uncommon. And we've mentioned that multiple times in a Leodanis, right? So if you're coming from another language, I think this would also be an excellent tour of the OOP in this language, and kind of some of the uniqueness and some of the gotchas and things you may want to be aware of, but also some of the breeziness of it comparatively to some languages that are a little stronger on structure and things like that. It's really detailed. And what I also was amazed by is that it never lost my interest. I really enjoyed going through it. And like I said, as somebody who had studied OOP from a handful of other books and some other real Python stuff, I think this is the best version of it in the sense that it really explains some of these concepts in a way that, I don't know. Have you had that teacher before where they explain something to you in a fresh way and you like suddenly, ding, it clicked for you, or that light bulb turned on. You're like, okay, I feel much more confident now if I was to explain this to someone else as far as some of that. And some of that, the standout gems for me, the explanations of instances versus sort of class attributes and then later methods, the way that self and that sort of word is used and introduced, I think really helped me sort of cement the functionality between instances and class versions of things. And there were lots of these kind of other unique things, which I'll mention as I kind of do like a summary of going through like some of the table of contents. He talks about something I hadn't heard of or hadn't run into directly. Maybe I've seen it and just breezed over it, but there's a concept of using slots in object-oriented programming in Python, and it creates sort of a lightweight class. And I thought it was presented really well and was very interesting. The other info that I tried to search for out there on the wider internet, beyond real Python, was kind of murky and very light on explanation. And I felt like this was a very good version of that. And it did a thorough job of kind of explaining like, why you might want to look at using that as a technique. He starts off with Python is a multi-paradigm programming language. And I think we've talked about that a lot across all these episodes of this show. There are so many people that come to Python and have various different goals and things they want to do, and almost like a choose your own adventure kind of book. And you can do object-oriented programming if you would like. And in Python, you do it through classes. And so this tutorial starts with just, defining a class, creating objects from a class, accessing attributes and methods. All right. So that's usually like maybe a first chapter before. And he gets into a little more advanced stuff pretty quickly right after that of public versus non-public members and the naming conventions involved in that. And then he dives into the benefits. Why would you want to use classes and deciding when maybe you would avoid using them. And then he kind of gets into working with data and attaching data to classes and in instances. And again, this is one of those reasons where you might think, does it make sense for me to be defining classes, or are there other sort of structures in Python that maybe would be a better choice? Everything doesn't have to be a class like some other languages. This is when he gets into the lightweight classes with talking about slots, and he dives into behaviors with methods and getter and setter methods, why you'd want to use those versus properties. Again, there's an off-ramp there. You can go into a much deeper tutorial. And then at the end of that whole section, kind of like this beginning course on OOP, there's a summary of all the above. Then it dives much deeper into all these more advanced sort of ideas, exploring specialized classes that are inside the standard library, looking at data classes, looking at enumerations, using inheritance and building class hierarchies. So simple inheritance, class hierarchies, extending or overriding methods, multiple inheritance, MRO, the method resolution order. And then some stuff that I think is really interesting, stuff like working with mix-in classes. What are some of the advantages of working with inheritance? He also decides to dive into a couple alternatives to inheritance, delegation, and dependency injection. And then a short area about abstract base classes, ABCs. Maybe you've seen that before. And this idea of interfaces, which I think is really fascinating and is like kind of the idea of maybe you work in an organization and you want your classes to follow structural sort of guidelines. As people create other things, it has to be based upon this abstract base class. And if you don't follow those sort of interface sort of guidelines, it will cause errors during the development time and indicate that you're not following this sort of standardized structure. I think it's a fascinating area. This covers it briefly, but it does a good job of getting the point across. And then he talks a little bit about unlocking polymorphism with common interfaces. So a really deep dive into OOP in one single tutorial, covers many of the different areas. Again, depending on your level of Python and your experience with it, I think there's different ways to attack it, but just an amazing resource. And like I said, I enjoyed it thoroughly.
Yeah, I would really recommend it for folks who are experienced programmers coming from other languages, particularly those that are heavily on the object-oriented approach, right? So if you're coming from somewhere like Java, Python, the Pythonic approach tends to be a little lighter weight than that. And because it does have the object-oriented concepts inside of it, you'll often see people writing Java in Python, and finding that it takes a little while. And I'm guilty of it myself in other languages, right? So I go and try to write Python in my JavaScript because it's the same thing, right? It's the tool you learn. So, but particularly the second half of this, where it sort of gets into the details, and it's got some pieces of when you might use it, when you might not use it, and things like that, as well as sort of there's nuances in every different programming language as to how they handle certain things. And if you assume that it's going to behave the same way as the language you're used to, you might find you occasionally get stubbing your toe on something.
Yeah,
so
you just found the sharp edges.
That bit of a mixed metaphor. I don't think you stub your toe on a sharp edge, but that's whatever works. Cut your toes off, stub them, however it works. But yes, getting into the details of some of that kind of stuff is very very helpful for somebody who's I know what a variable is. I don't need that. I need to know more of the language intricacies kinds of things, because you might be coming to Python as a second or third language. So this kind of article is great for that.
Developing and running Python apps is challenging. You need to handle everything from setting up automated builds to designing a scalable and resilient infrastructure. Want to build, deploy, and scale in minutes? Koyeb makes it easy to deploy your full stack apps, APIs, and workers globally. With a simple git push, your app will be seamlessly deployed across the world on high-end bare metal servers. Thousands of Python developers are already deploying with Koyeb. No ops required. Enjoy simplicity, scalability, and stellar performance. Start deploying now for free at koyeb.com. That's KOYEB.com. And I already hinted at it, but you also have a Leodanis, and it's related.
as long and as exhaustive as that article is, there's something he didn't cover in it. And so there's a sort of a companion article also by Leodanis, and it's called Solid Principles, Improve Object-Oriented Design in Python. The solid in the title is in all caps. It's an acronym, and it's a mnemonic that gets used to help better object-oriented code. It's not a Python-specific thing.
Yeah.
It's a sort of an OOPS principles mechanism, but what he's done is taken the 5 items of solid and shown examples inside of Python. So the design principles, each of the letters in solid, it's an acronym. I'm explaining acronyms. Each letter stands for something. That's what it means to be an acronym.
It's amazing.
It's been a long week, and I've been teaching, and somewhere along the line, I'm hoping I was somewhat comprehensive and understandable. It may have even been in English. So the S in solid is single responsibility principle. O is open-closed principle. L is the Liskov substitution principle. I is the interface segregation principle, and D is the dependency inversion principle. That's enough principles for a whole school district.
Yeah, definitely.
Someone without kids shouldn't be this awesome at dad jokes. So anyways, like I said, the article's a guide through this and sort of how to embrace them with Python. I'm not going to go through every last one of these, but essentially he steps through them. There's an example or two for each. And really, these are just ways of thinking about how you're designing your objects and how you're working together. The single responsibility principle, for example, is your class really should only do one thing. And the example he gives is, if you've got a file manager object that's got read, write, and compress and decompress, you're better off to have, say, a file manager object and a zip file manager object in order to separate those two things so that you're not having, you don't have the compress and uncompress on a file that isn't going to be compressed or uncompressed. And the rest of them are similar sort of concepts. Solid is one of those that 2 or 3 of the concepts sort of overlap. There's these kind of vague, am I violating the open closed principle, or am I violating the interface segregation principle? But it doesn't really matter because it isn't really a classification thing. It's more of a, if I can keep these in mind as I'm writing code, I'll probably be writing better object-oriented code. And the principles are from a variety of places. I think 2 or 3 of them are from the same guy, and then the other 2 are from somebody else. And so someone I can't remember who it was, just sort of glommed it together and said, hey, these are all good ideas. We should be doing it all together.
Yeah. Was this something that you learned in other languages?
I've come across this before. It's not something I use directly. I think part of it was I had done enough object-oriented programming before I had come across it that it was sort of yay, that's a nice acronym that encapsulates what I already knew. So it's not something that I've ever personally had sort of gone back to. But if you're new to object-oriented design, this gives you guidance in how to approach your objects. I see it in Django, one of those places where it can get really messy really, really quickly. You can get into the place where you're using the object-oriented stuff for doing the ORM.
Yeah.
And then you're trying to balance out what you're actually doing as database design, but you're also trying to do object-oriented design, and because the objects are a proxy to the database, and you're going to violate one principle or the other. So having rules of thumb like this can be helpful when you're trying to think about how to structure some of this.
Yeah. Yeah, it's kind of moving you, through avoiding common mistakes that people dive into.
Yeah, it's more of a it's an architectural thing. It's a way of thinking about your code and how to design object-oriented stuff rather than hard and fast thou shalt not. And there are, with all kinds of principles like this, there's exceptions, and there's times to do things and times not to do things. But if you're aware of it, it hopefully helps you be a better programmer.
Yeah. So this next topic that we're going to dive into, there's a lot of buzz and excitement about. It's one of these that it dives really deep into a very specific area of what Python can do. And so that part of it makes it very interesting. And what we're going to have to learn as this story sort of develops is like, okay, where does it also go? I've provided a lot of resources, and this is the one that you were able to find even other additional resources and include them in PyCoder, so that we were like, well, we could make this be our sort of discussion point also. The first thing I'm going to mention out of the whole thing is an article that is on the fast.ai blog, and it's by Jeremy Howard. And he works for Fast.ai, though you should note that he's an advisor to this company that we're going to speak about quite a bit, which is Modular. So there's a little bit of, he's helping advise them, but he's also extremely excited about this thing. The abbreviated title you had is Mojo, a superset of Python, and it is actually much longer and more excited. Full title: Mojo may be the biggest programming language advance in decades. A lot of stuff happens with that idea. And he starts this thing sort of saying there were 2 moments in my programming that I got most excited about. And his first time was when he was able to write code with Visual Basic and have a single line of code run when a button was clicked. In his whole life of programming after that, this is the second time he's had that same feeling of excitement. The Mojo that's named here is a superset, or this idea of building on top of Python to add a lot of new language features that would help in the machine learning space. One of the key people involved in this project is Chris Latner, and Chris Latner has a very storied history. He's done quite a bit. When he was doing his PhD thesis, he started the development of LLVM, low-level virtual machine, and it fundamentally changed how compilers are created, and it forms the foundation of many of the really widely used language ecosystems of the world. He also launched Clang, C-L-A-N-G, which is a C and C++ compiler that sits on top of LLVM and provides the backbone for a lot of Google's performant code. And LLVM includes something called an intermediate representation, an IR, which is sort of a special language designed for machines to read and write. Instead of like human beings looking at this, the machines are writing code in a way that other machines would understand it, which enabled a huge community of other software to work together to provide more programming language functionality across wider ranges of hardware. After working with LLVM, he was at Apple and developed their next language beyond Objective-C, which was Swift, which leveraged a lot of the power of LLVM. A lot of people called it the syntactic sugar for LLVM. And then he started to work at Google. There was like a little stint. I think he spent a short period of time at Tesla and it didn't work out. At Google, he started to work on a new thing, which was called MLIR. And the reason I'm giving this history is because this is very much related to this. MLIR is multi-level intermediate representation. So it's taking the idea of the IR intermediate representation, that LLVM, and adding lots of different levels to it. It's a replacement for the LLVM IR for many core computing and AI workloads. So what's happened in computing is hardware has really changed quite a bit. It's no longer just a CPU or a multi-core CPU. It's hardware with, large, massive GPUs, graphical processing units, and sometimes something called a TPU, which I'm guessing is called a tensor processing unit. And there's also lots of other specialized hardware that's being not only in like server-based CPUs, but also it's, in your phone might have its own little machine learning chip or something like in it. So the idea of MLIR is that it would be able to create this multi-level version of the code that could be spread across all of that hardware, which sounds fascinating. And I would love to talk to him more about it and learn something, kind of, it's hard to explain, and I actually was one of the few times I'm like, well, maybe I should do like a chat GPT thing and have it explain to me, like, what's the difference between LLVM and MLIR. And it added some additional stuff to it, but generally it's hard to explain, in kind of human concepts. So beyond that, there's this introduction by this company Modular called Mojo. And Mojo the goal of it is to avoid what we talk a lot about on the podcast, which is the two language issue, where we talk about, okay, well, yeah, you're going to work in Python and it does all this sort of stuff. And then, somebody always says, oh, Python's slow. Okay, well, in order for it to be faster, we'll work about having things compiled in these other languages that we can kind of insert into Python. Things that maybe in NumPy, it's doing things in C or Fortran. Or we've talked about other kinds of modular pieces that we can add that are, compiled in Rust and are going to speed up those sort of portions of code and sending code down these multiple paths with compiled libraries. And the idea with Mojo is maybe we could do all of that within one language, that it could have the ability to write in a Pythonic style, the ability to add that kind of sections of code that you want to kind of switch into faster mode, if you will. So there's portions of it where you could say, instead of using def to define your function, you could use fn. That would then go into that faster mode. The trick would be that when you're defining that new function with fn instead, you would need to declare the types of every variable in that mode so that it can be compiled in that way. There's also this idea of using structs, where you can then have your attributes be tightly packed into memory so that they can be used in other data structures and you're not going to be chasing pointers around. The other thing that the language is trying to do is help with deployment. Statically compiling applications would provide much smaller and launch programs much more quickly and run quickly. And the idea that, again, could run across all this different hardware. So they're trying to answer a lot of things. I'll provide links to their sort of keynote, which is sort of showing off all this sort of stuff. But it really is an introduction more than anything. Jeremy Howard does a demo inside of the video where he has a Jupyter notebook open inside of their modular platform, and you can sign up for that. There's a waiting list. It's not open. Their intent is that this will be an open source language, but it currently isn't. It doesn't have a version number. It's kind of in this phase of like, hey, we're showing this off and we're going to invite people in to kind of play with it and learn about it and, kind of find some of these rough edges and see what they can do. The demonstration that they do is impressive. They throw out lots of numbers kind of showing things that it can do. One nice thing that he does is talk about, I had this conversation with Jody a few months ago where we were talking about sort of vector math and how NumPy allows you to do math across that sort of stuff very effectively instead of being inside for loops. And so it was interesting watching this sort of Python layout of for loops doing a matrix multiplication sort of formula as he's, writing it inside there and running it. And of course, it's kind of slow. And then he starts to do these sort of step-by-step optimizations that Mojo can provide by defining types here, defining different things here, and suddenly you're seeing multiples and multiples of much faster speed, and eventually getting to something like 4,000 times faster, which is pretty incredible if that's the type of work that you're doing. So this language is geared toward machine learning and AI, and definitely is going to help in those fields, it seems like. The question that I see, because I would say that's not the majority of the audience that we have, listening to this podcast, is, okay, well, what can it do to speed up Python for me and the rest of things that I do? The idea is the language should be able to work with Python, be able to import modules, and they show it working with matplotlib and some of these other kind of scientific things. I'm not sure, if this will be a solution for web development or user interfaces or other kinds of things that people might want to do with it. The language isn't complete. It's more of a working demo, currently optimized to really do that kind of stuff. Tuple support is very partial. There are no classes, after we spent all that time talking about classes today. There's very few methods for the types that they've already defined in there. Keyword arguments are not really in functions. If you're going to do imports, you can only do direct imports and not entire modules. So you have to do from matplotlib import, and then the specific thing that you want. Async IO is not there. Comprehensions list or dictionary comprehensions aren't there. So there's a big long list, and they're very open about it, saying, yeah, there's a little page on here saying, what are the current edges of this thing? And it's literally called roadmap and sharp edges. So it's definitely a very fascinating thing to watch. I'm intrigued that they decided to show it all right now. I think it's partly because it's sort of conference season. Chris Lattner left Google and started working at Modular AI in 2022. So they're about, 16 months in, I think is what they said. So I'm wondering if it's they want to kind of make people aware of it with this sort of explosion of all the AI stuff that's out there. So part of the discussion part, where I was going to bring Christopher here in, is there's two threads that we found on Hacker News. What's really neat about both of them is that as people are asking these kind of pointed questions, Chris Lattner and is Jeremy in there also?
Yep.
Are answering a lot of the questions people have, which is really cool. So it's kind of one of these things where it feels like these people are very involved with it, want to make sure that there aren't a bunch of bad impressions or falsehoods being spread out there, that they're saying, hey, this is, there are people that are complaining in these threads, like, hey, Objective-C and to Swift transition wasn't good. And he's like, yeah, I know it wasn't good. It got released as a 1.0. I was there playing with it in that early 1.0, and it didn't really do everything it needed to do. And then any code that you wrote, you had to completely rewrite, I feel like, in Swift 2, like a year later. So he's, I think, trying to avoid some of that with this language and from that experience. But anyway, yeah. So What are your thoughts, Chris?
Well, I like you said, they were both very active, and I think that's fantastic. And but it's also the internet, so it's like I'm going to try and school Chris Latner on compilers. No, you're not. No, you're not.
Yeah.
It's like he's forgotten more than you've ever known. Trust me, you're not. He's the couple and they're not even like one sentence responses. He's writing paragraphs about deep implications of compiler performance and how type systems work, and how it's kind of a spectrum, and this decision affects this, and why this causes compilers to take longer, and like just a lot of beautiful little nuggets in there.
Yeah.
But like I said, it's also the internet, right? So I've got, I don't like Swift, and I've got, Python packaging sucks. And of course, because someone said Python, we have to have, white space. Why don't you have braces? It's like, yeah,
exactly.
This is an article on Mojo. Like, what's your problem? But there was also a bit of back and forth. As you sort of said up front, the title is a little bit of bombast. So Mojo may be the biggest programming language advance in decades. His first write at it, he didn't even include the word language. So it was maybe the biggest programming advance in decades. And so one guy piled on saying, well, the two big advances of programming in decades is Stack Overflow and Chat GPT. And I'm thinking, well, those are two interesting choices. And so he added the language specific piece in there. And then, of course, somebody mentioned Chat GPT. So that turned into its own flame war. So gotta love discussion threads. But on one hand, you've got all these little nuggets of wisdom and people are asking good questions. On the other hand, you've got things like, Python with better performance is a faster horse, not a car. And I'm like, yeah, but at some point in time, if your horse is running at the speed of light, well, like, why are you making the distinction, right? Improvements are improvements. I'm optimistic about this stuff, even though it comes with a little bit of a hype cycle. Maybe I'm so immune to the hype cycle because of ChatGPT lately that this seems toned down.
Yeah.
But there are plenty of other people who've attempted similar things in this space, and none of them have replaced Python yet. And I'm not sure whether that's because there's gaps in them or whether there's roadblocks, but there's some very bright people who know compilers very, very deeply here. So if anybody's going to solve it, maybe it's them.
Yeah, it's fascinating because I feel like it's also attacking the problem in a slightly different way. This whole idea of the multiple levels in the representation, I think, is really kind of interesting and could really help with some of the stuff that they're trying to do with this. The performance gains. They were working, a lot of the team that's at Modular seems like they moved from Google. They were speaking at this TensorFlow conference in introducing MLIR, and we're talking about, kind of what they're trying to do with it and explaining it. That was like about 3 years ago. And I'll include the link for that too. And the explanations of the problems that they're running into, things got big real fast. Like some of the things that they were solving for models were fairly small initially. And I think just everything got huge very, very quickly. The idea of large became this, word that was attached to every single thing in machine learning and the AI space. And the hardware was still kind of the same size, it's still moving at somewhat like Moore's law, and so all these other pieces of hardware kind of came along. Well, here, bolt on all this stuff. And it's like, well, how do you even have it address that and work between that? So I can imagine that somebody who's working at that level, working on the compiler side, then also creates the language that kind of then can also take advantage of those things. Like some of the fun stuff that it can do, programming, whatever. But is it has some very interesting things where you can kind of have it sort of gauge its own level of optimization. It can kind of try out and sort of tune itself, which I think is really neat. Like having it auto-tune, like how this particular algorithm, will it work best with this many cores? That I think is really smart, and I haven't seen that in a language before. The idea of it being, you sort of pick and choose where you want to add this functionality, I think is fascinating also. And I appreciate that it's not a brand new language, like that it's still going to read the way that Python reads. I think that's really kind of cool. I mean, I know that person didn't like white space because it's difficult to copy things and move them around or whatever his complaint was.
That's the same. It's the same argument every single time. I can't copy and paste code. Okay.
It's like, okay, well, sorry, pay attention. You're doing it.
Yeah. Get ChatGPT to do it for you. You'll be fine.
Oh, yeah. Okay. Is that the same guy?
I don't know.
Yeah.
Jeremy touches on it in the article a little bit that because this is compiled, all the compilation stuff's happening on your local machine. It, in theory, fixes the distribution problem. You have a different distribution problem because now you have to target your platforms. But as in, I have to compile for Windows, or I have to compile for Mac, or I have to compile for Linux, or whatever.
And they don't really cover any of that. They just
they don't.
Right.
And quite frankly, we kind of do that within the Python community, anyways. Right? A lot of libraries are available via compiled wheels.
Right.
So I think that's an easier problem to solve. But being a Mac user who is the bottom of the totem pole on the targets,
sometimes feels that way.
When somebody says, this problem's solved, what I hear is, and so there won't be a distribution for you. So
yeah,
it'll be fine. You'll just have to brew something and then install the brew thing of the brew of the home brew.
Yeah.
And then, so
I was definitely having that problem with things like TensorFlow and some of these other larger models that I wanted to play with. And it's like, well, I bought a new Mac. And it's like, oh, sorry.
Yes.
It's like, okay. And so like the versions, we're using versions of Python that are several years before this version of the Mac came out. And it's like, okay, well, I'm not sure, how to make this get set up for it. And there were explanations, but it was very, very convoluted. So I'm hoping that will help with kind of modernizing some of that too.
Well, it'd be interesting to see what comes out of it.
Yeah, the second conversation was it started by Chris Latner? I don't know. That's the first post that I see on there. Its title is Mojo, a new programming language for AI developers. So yeah, I don't know if it's going to answer the general purposeness of Python. Like I'm not sure if that is part of the targeting or not. And there are lots of very specific problems that AI developers and ML developers have. So I don't know. It'll be interesting to see, what happened there, or what will happen there.
The advantages of a closed beta, it somewhat solves the Swift 1.0, 2.0 problem in the fact that you're able to control who you're letting see it. And if you have to make a big change, the people who are playing with it know that, right? They understand that it's beta.
Yeah.
The disadvantage of it is, you hype it and then everyone goes, well, does it do this? And you don't know, and no one knows how, you're limiting where you're getting your feedback from, right? So it's a bit of a pros and cons approach. And you're always sort of, you see things like the promise that says, oh, we will open source this. And it's like, okay, let's talk about it when you do. So
right. Yeah. Because that's kind of what happened with Swift. The idea was like, hey, we're going to open source this, and this will be the thing for servers, and this will be the thing for ML, and and I think Google and the community tried, but it just never took off. I don't know the complete story there, but
fundamentally, open sourcing means somebody can fork it.
Yeah.
That doesn't mean there isn't a committee completely populated by one company, or mostly populated by one company in charge of the official release. And so you get varying degrees, right? And similar political things have happened with Java and Oracle, right? Like there's always that balance. The difference with Java was far more out there before Oracle started trying to clamp down on things, right? So there's the big companies, to a certain extent, kind of want their cake and eat it too, and sometimes that limits the reach of the language.
Right. Yeah. All right. Well, I'm fascinated.
Yeah, be interesting to follow it along.
This week, I want to shine a spotlight on another Real Python video course. It provides a thorough introduction to one of the most famous machine learning algorithms. The course is titled Using K-Nearest Neighbors in Python. It's based on a Real Python tutorial by Jos Kortenj. And the video course is presented by previous guest, Kimberly Fessel. And she shows you how to explain the KNN algorithm, both intuitively and mathematically, how to implement KNN in Python from scratch using NumPy, how to create a model and make KNN predictions with scikit-learn, and how to randomly split your data using scikit-learn's train test split, and also how to adjust hyperparameters and score your prediction. K-nearest neighbors is a great place to get started on your Python machine learning algorithm journey. And this course is a worthy investment of your time. Like all the video courses on RealPython, the course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. What's your next one?
So this is a quick little article called How to Have Python Show Warnings When Running Django by Joseph Victor Zamet. As the title implies, the advice is for Django, but really it's just about command line options available to Python, which then you can use if you're running Django's dev server, for example. So the content is kind of helpful even for non-Django programmers. CPython supports a command line flag, which is -W, and that controls the warning level. So by passing in -WD, you get any warnings that are issued in the code the first time they're issued. So you don't just keep seeing the same one over and over again. And you can actually get that one I'd heard of. This I wasn't aware of. You can get much fancier than that. You can do -W space and then like generalized token things like ignore > deprecation warning, all one word. And that will show all of the warnings except the deprecation warning. So you can actually go in and fine tune this to an extent that I was not aware of. Alternatively, there's also something that was a little more recently added, which is called dev mode. This is also a command line flag. It's passed in with $X and then dev. And dev mode turns on certain kinds of warnings as well as some other stuff. And you can also set Python dev mode as an environment variable. That's all caps, one word. And setting that to 1 essentially does the same thing as doing -X dev on every single Python instance. So these are just different ways of controlling what Python complains about and gives you a better idea with warnings as to whether or not your code, if something's being deprecated, you should be replacing it, that kind of thing.
Cool.
So for the Django specific bit, when there's a control script inside of Django that runs a whole bunch of different kinds of commands, the primary use it gets used for is to run the development server. It's called manage.py. And so instead of using, say, if you're on Unix, /manage.py, you can always say Python space manage.py. And because it's just a Python script like anything else, you could stick those flags in it. So, for example, you could do Python -X dev manage.py run server. And there you go. You've got your deprecation warnings coming out when you're running Django, and you can fix them and clean up your code so they don't blow up when things change.
Good. Nice. So that takes us into projects. And you shared this one with me, and I started to play with it, and I really like it. I guess it's been around for a while. The name of the project is TQDM, and you shared not only the sort of package with me, but also sort of a quick kind of tutorial that's by Siddiqui on Coder's Legacy. So I'll include both. And the idea behind TQDM is that it's a progress bar for your Python programs, and you can use it, within the console as you're seeing output as you're, running your code. It's really easy to use. I was really impressed by it. You just import TQDM and you wrap it around whatever iterable that you're, wanting to watch the progress of. So if you're, doing like a for loop, let's say you're using range or something like that, you could do, for I in and then TQDM parentheses and then whatever, you could put range or whatever the iterable is. And then it, as the thing is progressing, it just shows in the terminal the progress as it's walking by. It's actually doesn't use up a lot of processing power. It will work in all standard terminals, Windows, Mac, Linux, or within a Jupyter notebook. It doesn't require any dependencies, not even curses is what they put in there. It's just Python and an environment that can support carriage return and line feed control characters. The article goes a little further than what's shown in the GitHub, showing how to customize it a little bit, how to kind of change some of the animation, how to use different characters or colors or ASCII art to create some nice techniques of progress bars and kind of seeing it progress as you go. If you have loops within loops, you can use it multiple times and it would show multiple progress bars as it completes one section to the next section. And it's a neat little project. And if you ever needed a quick progress bar for your Python program, this might be a handy little tool for you to add.
Yeah, the one caveat with it, which kind of, I think maybe goes without saying, but if you're piping something like generators through it, it has to sort of turn it into an actual thing because you can't show progress unless you know how many items are in the progress.
Yeah. Okay. Yeah.
So that there's a little bit of a performance caveat. Yeah.
Iterable.
Yeah. Because otherwise you can't do a progress bar. You need a spinner because otherwise you wouldn't know how big your generator is going to be.
You don't know when the end is. Yeah. Okay. Cool. What's your project?
This week, we're going to close up with something called Frogmouth. It's from the folks at Textualize. You may know them as the terminal people. They write tools for making your terminal more powerful, and they include libraries like Textual and Rich. Been getting a fair amount of press on Twitter and places like that lately. Frogmouth is a Markdown viewer, and it uses the textual toolkit. So it's simultaneously a useful little tool and a bit of a showcase for how you could use textual. So you can either use it as a tutorial for writing textual stuff or just use it as a Markdown viewer if you like. It's Python, so of course you pip install it, and then once you've done that, you've got Frogmouth available as a command line tool, and you run it passing in either the name of a Markdown file or a URL pointing to one. Took me a minute to figure out that some of the menu interaction was mouse-based, but once I did that, everything else went smoothly. Kept going, how do I do that? How do I click on that? Why isn't that working? Oh, maybe I use my mouse. There, it works. But otherwise, it does a really good job of rendering the file and distinguishing between the different kinds of tags inside the Markdown. It's a beautiful looking piece of code, presenting the output nicely. It also supports a sub-command called GH, allowing you to directly load from a GitHub repository. So, for example, frogmouth GH textualize/textual loads the README file from the textualize/textual repo. The first time I did this, it blew up some sort of connectivity error. I think my network glitched, and it had the prettiest stack trace I have ever seen.
Okay.
And that's textual because I know it's got a bunch of colorization pieces in it. The second time I ran it loaded fine. So the feature's kind of handy because you frequently, what you're trying to do is you want to look up the README file of something in a repo somewhere. And now you've got this on the command line. My one complaint, and this echoes something I think we talked about a couple episodes back, is they didn't use a flag for GH. Like it's not --GH, it's just GH. And so I'm sort of looking at it going, well, but what if your Markdown file is named GH? And they were smart enough to figure that out. It does work.
Okay.
I did not break their code, but it's a weird kind of overloading, and it just it throws my OCD. So, Will, if you're listening, this should be a flag, but that's my only complaint, and it's a nitpick. So otherwise, interesting little library to check out.
Did you mention the pipx thing with it?
No, I didn't. So if you're not familiar, pipx is a tool that is pip plus execution, I think is what it's sort of supposed to stand for.
Yeah. We dove pretty deep on it with Calvin.
Okay.
A few months ago. It's kind of like setting up your terminal with a bunch of tools and, creating your environment. It's neat because it's very easy to sort of install it and then also uninstall it. But yeah, it supports doing it with that.
Yeah, and Frogmouth will work with it as well. So if you've got like a common outside tools, it's basically a common outside tools environment, so that you're not having to say run your virtual environment for it. So yeah, you can use pipx with it as well.
Yeah, cool. Thanks again for bringing all these articles and projects this week, Christopher.
Always fun.
And don't forget, you can deploy your Python apps globally in minutes for free with Koyeb. Head over to koyeb.com. and start deploying for free today. That's Koyeb.com. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.